Hello and welcome to Computer Tech and More. Today we're going to be doing my revamp series. I recently updated my testing methodology, so I'm taking a look at fans that I previously looked at. Today we're going to be taking a look at the X2-GP14 case fan. It is a feature fan in the Torrent PC case as one of the bottom 340mm fans. Let's get right into the data and see if my original thoughts still hold up about this fan, or has its performance, meaning in the noise performance, because that's what's changed, completely overhauled its position. Let's get right into the data. Alright, first up is previous data versus current generation data from my previous testing methodology to the new technology. These are the number of 140mm fans that I've tested thus far. And we can see that the X2-GP14 originally ranked 13 in CPU AirCooler noise normalized testing, while previously it ranked 8th. So its RPM has actually dropped a little bit. Its airspeed has dropped a little bit respect to my original testing methodology. What this means is that it's relatively speaking noisier for the new normalized noise value that I've decided to take. And I've listed out the other fans that are also in this category. Moving on to the next set of graphs, and this is a fan at 100% RPM, and the value is exactly the same. It hasn't changed position because it's going balls to the walls full speed as opposed to trying to noise normalize it, so that makes a lot of sense. Looking at CFM noise normalized, so CFM is when I hooked up my fan to a tube and get the measurements that way. Originally it tested at 13th, now it's ranked 14th. So it's again dropped a little bit in performance, but this time not nearly as much. It did lose 4 CFM and lost a little bit of RPM, but overall it's kind of middle, well actually it's kind of towards the bottom, but not a bad result in my opinion. Moving on to 100%, it's the exact same positioning, 15 and 15. And moving on to noise normalized, so all the case fan simulation tests are noise normalized, and it went from 6th to 7th. So again, it dropped back a little bit in performance because of that noise normalized value. It's lost a little bit of that. And the new noise normalized value is 13 decibels by my readings, if I'm recalling correctly. And so it's just a different value because it's a different way of measuring it, while before it was 42, and that was with the microphone placed up next to it. While now I have a fixed, basically, device that I'm using to separate the microphone from the fan at a fixed distance. At the 11-inch mark, it's gone from 6 to 8, so it's actually in the middle of the road here. So it's a very good case fan. And in terms of its value proposition, it went from 8th to 11th with a value of 0.6 to now a value of 0.53. You can see it all in the graphs. And in value proposition for 11, it went from 11 to 11, so it didn't change position at all there. In terms of cooler, it went from 10th to 12th. You can see the value listed on the graph. I highlighted it in red. And at cooler 100%, it did not change its value proposition. And CFM value, noise normalized, it went from 14 to 13, so it actually improved in value here, relatively speaking, to the other fans in this short roundup. And at 100%, it did not change position, which, again, makes a lot of sense. Okay, on to the real new graphs and data. All right, the first set of graphs here is in my case simulation test. The case simulation test allows for doing a variety of tests to simulate a variety of different case sizes. And you can look at it in a couple different ways. The first way of looking at it is, how good is this fan at creating a concentrated airflow? The most ideal fan in the world that could ideally be produced would basically create a nice column of air that shoots out directly behind the fan and doesn't spread out at all. So go from front to back in just this perfect column of air. That would be the best fan for getting to your CPU cooler and, well, through the case. But we don't live in an ideal world because, well, the fan has to push through more air, and that air has a tendency to spread out, the air that it's trying to push. So what we're looking for is as little drop in air speed as possible over the length of the case. That indicates that the fan is creating a good concentrated push of air and not completely letting it dissipate everywhere in every whichy way. You do want air to travel from the front of your case to the back of your case through a nice clean flow path. And so that's why this is very important. You don't want to see the fan just completely drop off right at the beginning. That would indicate a very bad performing fan for case airflow. The second way to look at it is as actual case sizing. So I took key measurements at 6 inches, 9 inches, 11 inches, and 14.5 inches. 6 inches represents a small form factor case that still is more or less a standard type layout case. You still have air moving from the front of the case through to the back of the case. Or you're flinging air up from the bottom of your case and it's going directly into your GPU. That would also be a very applicable application for using that 6-inch mark. The 9-inch mark is representative of a small compact tower, something like I can't think of one on the top of my head, but basically a very compact tower case where it's still a front to back airflow flow path. 11-inch is basically a bog standard mid-tower case, something like the Meshify 2 or Meshify 2C, I forget, whatever the mid-tower is from Fractal Design, or maybe the Corsair 550D, that's one I had, and that's where that measurement comes in. And the last one is 14.5 inches, and that's representative of a big case, something like the Fractal Design Torrent, which is another case that I used. And I took a lot of different cases to take an average for these measurements to get these results. And then I took measurements at 20, 40, 60, 80, and 100% RPMs. And if you're looking at an RPM range in between it, well, you can say that the results would be fitting somewhere in between. And you can see that the X2-GP14, the Fractal fan that comes in the Torrent case, is actually doing fairly well overall. Its line is got a fairly slow descent. It just doesn't drop off right away, which indicates a very good result for it being a case fan. But this is taken in a vacuum. We need to compare it against something else. So here are my noise normalized values for distance versus airspeed. The red line is the X2-GP14 running at its noise normalized RPM. The green, aqua teal color is my control fan, and the control is 3 parts A12X25 to 1 part A4. Yes, the NF-A14, which I consider to be good fans in the respective categories. So that's why I use that as my control. And the last fan on this as the green line is the X2-GP18, and that is the 180 millimeter size fan that is also featured in the Torrent case. Next up, we're taking a look at how the fans look at 100% PWM fan signaling. So again, the line colors are all exactly the same. We see that the X2-GP18 is actually outperforming all the other fans, which makes a lot of sense. A bigger fan is able to push a larger amount of air from the front of the case to the back of the case, but they're not as good at pressure type applications. So it makes a lot of sense that it actually has a very flat line and is outperforming the other fans. The X2-GP14, on the other hand, actually puts up some very good results until you start getting towards the end of the bigger case, where it actually drops off in performance quite dramatically. As to why it actually starts to dissipate so much after 11 inches to 14.5, that's much harder to tell, and it would require much more extensive testing that I don't quite have resources to acquire yet. So if you really like my videos, the presentation, the data, please join my Patreon page. Everything that I would earn off of that would go directly into making these videos to get better equipment to improve my testing, microphones, and buying more fans. But then, anyways, back to the data. Here's the control line, and you can see how things stack up. And how does it compare against other fans? Well, here's a small sampling of fans that I feel like are representative of very good fans, kind of the middle of the road fans, and then not so good fans, just to get a broad spectrum of information without showing every single fan on one graph, because it would get very convoluted and hard to tell what's going on. So the X2-GP14 is sitting towards the bottom of the pack. Not that that's necessarily a bad result. We would need to compare it against the 120 millimeter size fans to really be able to fine-tune that data a bit more. But it's and that'll be in an upcoming video. We're going to have a broad comparison of 140s and 120s. But anyways, back to this. You can see that the Storm T3 is our bottom performer. The X2-GP14 is kind of in the middle. And our top performer here is the SilentWings 4 Pro 140mm size fan. Again, this is all noise normalized to my 12 decibel reading with the new testing methodology. And then we have these upper ones where this is the X2-GP18. So, what else do I want to say? We have the RPMs listed there, and these are all the same noise level. Let's take a look at 100% PWM fan signaling. So on the graph legend over here on the right side, we have the fan name, the RPM was running at, and the noise level. Oh, I forgot. This red line right here is the A12X25. So that's kind of the fan to beat in terms of case airflow. I'm sorry, I jumped back. Anyways, let's keep moving. Now we're back onto the 100% ones. And the SilentWings 4 Pro 140 is our top ranked fan. It is spinning at 2,400 RPM at 31 decibels. So it is a very noisy fan indeed. The A12X25 is sitting here basically in the middle, although it drops off quite steeply as compared to most of the other 140mm size fans. So the X2-GP14 actually puts up some very good results until it reaches that 14.5 inch mark, where it drops off heavily and really isn't a top performer. So if you're looking at a case that is a mid-tower or smaller, it's looking very, very good, especially compared to other 140mm size fans. Moving on to our 9-inch case airflow airspeed versus decibels. So the 9-inch mark is sort of this middle ground between, how should I say, 6 and 11. Ha ha ha. But that's where most fans tend to drop off. So fans that don't create a good column of air tend to drop off at the 9-inch mark, while fans that still produce great airflow are doing still really well at the 9-inch mark. While 11 inches tends to where it gets really hard for me to actually collect good, consistent data with my current test equipment. So we're using this as the validation point for airspeed versus decibels. Because 6 inches, just all the fans tend to do really well at that point. So the X2-GP14 is sitting here pretty much right in the middle of the pack. This little joggle here is where it got a lot more performance for almost the same noise value. So that is, if you're asking why that happens, well, it could be that that is just where the fan's blades become efficient. Some fan blades are efficient at all RPMs or have the same efficiency, while others need to reach a certain RPM, a certain amount of airflow running past it before they become efficient. And I think that's just where it happens for this fan. And other fans you'll see, like the SilentWings 4 Pro 140, they use big joggles off to the side. Well, that's indicative of me hitting a harmonic frequency within the fan or my whole testing apparatus where it just causes vibrations and thus increased noise values, so it gives a arbitrary loss in performance. Unfortunately, that's just what we're seeing here for them. But this is our good comparison data. And right at the bottom, we see the Storm T3. Right above that, we see the NFP14S. At the top of the graphs, we see the SilentWings 4 Pro 140. Kind of in the upper middle, we actually see the X2-GP18. It does really quite well overall. And the A12X25 is sitting here. It doesn't do very well, and then it kind of kicks in and creates good, steady, middle-of-the-road performance in terms of its airspeed. Next, we're taking a look at airspeed going through my CPU air cooler. My particular cooler is the U12A Noctua air cooler. It is a thicker single tower cooler, which I think represents a good middle ground between a standard two tower fin stack and well, less densely packed single tower fin stacks and kind of radiators and AIOs. because I don't have access to a radiator right now, again, more equipment would like to get my hands on, a good, solid, high-density, thick one. It is the closest I can get to a mix between how a fin stack would operate for airflow and for pressure-type applications. So, on the left graph, we have RPM versus airspeed. RPM is the horizontal, airspeed is the vertical, and this graph is representative of how good is the blade design on the fan. More efficient blade designs are going to outperform, so better performance is going top left, worse performance is bottom right, as opposed to my control fan. And that is how much air can the fan blades push at a given RPM. So it's literally how good the blade design is. On the right graph, it's noise versus airspeed. So this is how efficient is it in terms of noise. Again, the graph is set up the exact same way. Better fans are going to be in the top left, worse fans are going to be in the bottom right. And let's go back to the left one real quick. We see the X2-GP14. It is underperforming my control fan at lower RPMs, and then it actually outperforms it as RPM increases past approximately 1,200, I would say, 1,300 RPM is where it starts hitting its sweet spot in terms of performance to airflow, or RPM to airflow. In terms of its noise performance, however, it just doesn't quite stack up as well as the control fan, what we'd like to see. So while it's good at pushing air, it's not that good at doing it quietly. Well, how does it stack up against other fans? Well, this is, I think it's actually might be all the fans from my 140 millimeter class, because I don't have as many of them at this point. So it actually does stack up towards the bottom, not that that is necessarily a bad result. Again, it is behind the control fan for 140 millimeters, or my control fan. And some keynotes that I want to talk about with this data. Over on the right side, you're going to notice a numbers W equals another number. And that is from my maximum cooling test that I did for my U12A cooler. I basically ran the Noctua A12X25 and the Be Quiet Silent Wings 4 Pro through that cooler at their entire RPM range, and figured out what each airspeed was related to a wattage, just letting the CPU do whatever it needed to do for a given load. So temperature was the basically fixed variable at 91 degrees, where that's the maximum thermal temperature of the CPU, so it wouldn't go beyond that. So the air running through it would just try to keep the CPU below that, and it would just give me an output of wattage. So I was able to create an estimation of what a given wattage, or what airspeed would indicate a rough wattage. So if you have a fan running at 0.5 meters per second of airflow, you're going to get 130 watts with one fan. So our X2-GP14 at 0.8 meters per second of airflow is going to get us 145 watts with one fan. Maybe 150, somewhere in between these two values. So how can you use this data? Well, the U12A is for 120 millimeter size fans, so this isn't exactly realistic for this 140 millimeter size class, but what it does give you is analogies. So let's say you had the X2-GP14. Well, if you upgraded to the NFA14, I know this is the 3000 RPM version, but at that same noise level, you're now going to be pushing 1.1 meters per second of airflow, which means that you're now able to push your CPU to 175 watts. Or on your particular cooler, you'll see an improvement in wattage. How much improvement in wattage is harder to say, but you're going to see an improvement in how much thermal load your cooling system can handle for that given noise value. Now you could also take that extra overhead, and let's say you find my noise value noisy, you could then turn it back a little bit, and now the fan is quieter than your original fan. So that's how you could use this data kind of going forward and apply it to your particular cooler. Now moving on to how does this fan do at 100% PWM fan signaling. Again, we got the wattage calculation over here off to the side, and we see the X2-GP14 is still kind of towards the bottom, but it's honestly not a terrible result, 1.8 meters per second of airflow. And at this time, I'm reminded to say what my error in calculation is. So if we're looking at noise normalized and these values, we see the RPM and a noise value as well as an airspeed. So my anemometer, just the device used to measure airspeed, is accurate within 0.1 meters per second. So fans that are within 0.1 meters per second of airflow of each other could be considered functionally equivalent. So the Unifan SL140, which is at 1.7, and the X2-GP14 could be considered within error. However, I run the test several times and create a calculated average, and the X2-GP14 does average out better than it. So I'm confident to say it is outperforming other fans and that the positioning of them is accurate. But there is always an error in doing calculations. The next is my noise value. So when I do noise testing, I let my house get as quiet as possible, and that's about 30 decibels. I put up foam panels around my testing apparatus to make it as, well, sound isolating as I can with my current test setup. I place my microphone at its fixed, consistent distance, and I take a reading. It is accurate within 2 decibels with the current testing methodology because I pause any testing when I notice any extraneous noises going on around the house. So 2 decibels with noise and 0.1 meters per second with airflow. Okay, moving on to cooler performance versus decibels. So again, better fans are going to be in the top left, worse fans are going to be in the bottom right. And the X2-GP14 is highlighted in pink. And we see its sharp increase in performance, like we saw in the previous graph, or previous graphs a little while before. And that just indicates that the fan has hit a particular sweet spot in its performance where it gains a lot of performance at that given airspeed. We have the AF140 Elite, which is kind of beats it and then doesn't really do as well. While the top performer here is the NFA12X25, which shows what a high-performing fan can do. So all these fans were selected because they had similar characteristics to the X2-GP14. Okay, let's move on to CFM. So CFM I don't really like as a test because it's basically a pure scientific test. Sorry to say, it doesn't really take much knowledge to run a CFM test. You put the fan against a tube, you let the air run down the tube, you have an anemometer sitting at the end of it, you get an airspeed reading, you know what the internal surface area is of that tube of any shape, and you know what the CFM, cubic feet per minute, airflow coming out of it is. You're not really gaining any information about how it's going to work in a case, and you're not gaining any information as to how the fan is going to work in a radiator or a heatsink, which is why you need specific tests as opposed to the CFM test. But CFM does have one sort of good piece of information to it, where it's fundamentally similar to blowing air through a lightly packed fin stack. So if you don't have very high fin density, it should give similar results to that, but otherwise not really that much information. So coming back to how it tests, you're putting the fan against the tube and it's blowing all the air down. So if a fan has a tendency to shoot air off to the sides, blowing it wide, I'm using my mouse cursor to indicate it's blowing air wide, it's still going to show relatively similar performance to one that blows air straight back in a column type fashion. However, there will be slight differences because the amount of air that pushes forward will be different to them, so momentum loss, that kind of thing, but they'll look more closely rated to each other than they should be than what we would see in my case simulation test, which is why I don't really like it, and a lot of fan reviewers use this verbatim and they don't understand what they're actually testing. I actually am an aerospace engineer. I understand this stuff. Okay, on to our actual results now that I finished ranting. The X2-GP14 basically has very little performance improvement, and then boom, gains performance. However, we see that it's not performing all that well compared to the control here. If we jump over to noise versus airspeed, we again see that it's not doing that well. If we take a look at how it compares against other fans, it's once again not performing particularly well. It's towards the bottom. And this is the noise normalized one, once again, 44.8 cubic feet per minute of airflow. And when we take a look at it at 100% CFM, it is dead last. So why is it performing so badly? Well, that's kind of hard to say. So I found that some fans that performed really well in radiator and case airflow testing do absolutely horrible in CFM testing. And I think it's got to do with the anemometer sitting at the back of the tube, and some of the fans just don't have a strong enough motor to, well, push past it. So it's actually creating too much resistance back with the anemometer there, and it's creating so much back pressure that it's hurting a lot of the performance with these fans. So it actually might be a good indicator for performance for very restrictive airflow. But without further testing and further support from viewers like you, I really can't do a deep dive into that at this time. All right, now we're on to the last section of my video, and this is the value proposition. So before I start going through the different value propositions, I want to talk about how to use this data. So if you're on an ultra tight budget, like money is the most important thing to you, well, money is very important, but if you're on a very restricted budget and you don't have very much extra money to spend on niceties, this is the type of information you're going to use 100% specifically as opposed to the other graphs. Because here you're getting the best bang for the buck, which is the goal. If you have a little bit more of a budget, a little bit more wiggle room, you want to get a little bit better noise performance, you want the fan to have a certain aesthetic, RGB lighting, whatever your particular case is, that's where you use this information with the data from the other graphs to then pick out the best fan to performance ratio that you prefer. And if you've got unlimited budget, well, I'm not sure why you're here, because you're going to just pick out the best fan anyways. But maybe it's a good way to justify your spending. Anyways, if we take a look, the X2-GP14 is sitting at, sorry, I need to do one further explanation. So on the left side, we have the 6-inch noise normalized. On the right side, we have 100%, and that's going to be kind of similar as we go forward, where noise normalized is left, 100% is right. Okay, the X2-GP14 has a noise, or a performance ratio, so it's meters per second divided by dollars, for its value proposition of 0.53. So how does that rank to other ones? Well, I'd kind of call it just a little bit under middle of the roads. It's not terrible in terms of its value, but it's far off from the best. The TLG12 was the top performer in this category in my previous test analysis, and it maintains that with the current testing methodology. It is just by far the best value proposition. But if you're looking at 140 millimeter size fans for the 6-inch mark, the Storm T3 140 actually does quite well. If we take a look at things at 100% PWM fan signaling, we see that it's at a 0.91 in terms of its value proposition. It's kind of in the middle, but again, it's still a far cry off from the top performers like the TLG12, the P12 Max, and even other ones in the 140 millimeter size class category. The Storm T3 still does particularly well here. If we're taking a look at things at the 11-inch mark, so now again we're looking at mid-tower and bigger cases. The X2-GP14 is actually kind of towards the top, but middle top in terms of the 140 millimeter size category. When we're taking a look at everything in, or more different fans, it really can't hold a candle against the TLG12. Still, that's still just the top performer. So you can't have it all. So if you're really in the top value proposition, the X2-GP14 really isn't a top pick, but it's not like it's terrible. So if it's in your case already, stick with it. If you're buying all new fans, get something else. Taking a look at 100% PWM fan signaling, it's kind of shifting towards the top in the 140 millimeter size, but it's still just blown away. Once we're taking a look at things in a CPU cooler, well, it's really not performing that well, and you can see where the top performers are. So I'm going to just move on to 100%. When we're taking a look at the 100% category, highlighted in yellow, it's still kind of in the middle, but it's not that great a value. It's just not a top performer in the value proposition. And last, but certainly not least, is CFM. And once again, we see the same sort of trends where it's kind of in the middle, but kind of at the bottom middle in terms of averaging out everything. But once we take a look at other fans, it's just kind of behind everybody else. So sorry to end that on a downer, but what do I think of the X2-GP14 overall? Well, it comes in the Fractal Design Torrent case, so I think overall it's a good fan to not need to just go out and replace it right away. So its noise value is actually not bad. Its overall air performance, how much air it pushes, is actually pretty good. So it's a good fan, but it's not good to just buy on its own. So if one of them goes out and dies, I wouldn't buy another one. I'd buy a different fan. But if it comes with the case, you should go ahead and use it because that's why you bought the case. All right, let's kind of wrap this up in